My goal is to take this equation and put it into vertex form. So the first thing I'm going to do is I'm going to isolate the x terms. It'll be easier just to work with these terms, so I'm going to subtract 5 to the other side. So I have negative 5 equals x squared plus 6x. Now, to complete the square, I need something right here. So the first thing I'm going to do is if I had a coefficient here other than 1, I would factor it out, but since I don't, I'm going to complete the square. X, half of this term, is 3. So all I did was divide that by 2. And 3 squared is 9. So what I did, looking at this row right here, is I added 9 to the right-hand side, which means I need to add 9 to the left-hand side. And when I do that, I get 9. All right, so the next step is to put it into function form, so this 9 has to come back. So I have f of x equals, except that shouldn't be 9. Let's go back and look at that. What should that number be? 9 minus 5, it should be 4 that needs to go over. So I have x plus 3 squared, and if I bring that to the other side, I'm going to subtract 4, and I get minus 4. Now, what I would do in my calculator before I go any further is in L1, I would graph this. In L2, I would graph this. And if they are exactly the same, then you know you did it correctly. If they do not line up on top of each other, do not move on. So now I have two equations that I can find different things from. So let's start with the vertex. Well, vertex, I'm going to go to this equation right here, and I know the vertex is the opposite of 3, negative 4. So negative 3, negative 4 is my vertex. My axis of symmetry cuts that in half. So I can say axis of symmetry is the equation x equals negative 3. Next, the y-intercept. The y-intercept is pretty easy because we're going to plug in a 0 for x. Now, you have the option of going to this equation or this equation. Well, if I go to this equation right here, the top one, and I plug in a 0 right here, which makes it go away, and a 0 right here, I know that my y-intercept is 5. So 1, 2, 3, 4, 5. I know there's a point on the graph, which is 1, 2, 3 units away, which means 1, 2, 3 units away, I have another point on my graph. The x-intercept, we can do it in a few ways. I can go back to this original equation right here and factor it. X plus 5 and x plus 1, which means x equals negative 5 and x equals negative 1. So the points negative 5, 0 and negative 1, 0 should be on the graph. Negative 1, 0, 1, 2, 3, 4, 5. Well, that's exactly what we want. Notice those are the same distance from the axis of symmetry. Now, I can complete my parabola and answer a few questions. The domain is all real numbers. The range is y and the y value, and my graph is above it, or I could write it as negative 4 to infinity. So just putting something into vertex form can help you quickly sketch a graph of your parabola.